Hey there folks. So in this video we're going to be extending our exploration of PCG, and this time instead of looking at how we can use the angles of the slope, what we're going to be looking at is how we can use the height of the landscape or the height of the placement. So you can see here I've put this previously created ground cover kind of PCG, so it's got all these different elements like all the flowers and things. I've put this on as a volume over a very bumpy landscape, and what I'm going to do is I'm going to use the different height values here in order to filter out so that we can have potentially only certain types of plants growing. Maybe the ground cover only grows on the top of the hills, and we can remove it from the lower down areas, or at least filter it out so we can grow and put other plants down on the lower ground areas as well. Okay, so I'm here now inside of this PCG, and you can see there's some very simple stuff that we're doing here. There's the ground cover spawning we've done previously, and all this is doing is it's just taking a whole bunch of points, saving them into a named reroute, and then I'm just filtering that out. So I've got the lower 10%, the middle kind of 80%, and then the top 10% there. And that's just spawning these different ones. So that's the reason why we can see some greens, some purples, and then lots and lots of mid-ground cover. I also have this bush one here, so I've got a different surface sampler with different sizes to it. I'm filtering out to only show the top 30%, named it as bush points, and then I'm using that to spawn a whole range of different bushes all over this area as well. So things that we've already done before, but just experimenting inside of here. Okay, so how do we actually do the height density? Well, when we've done previous ones, what we've done is we've right-clicked and we've searched for the node that we want. Here we got normal to density. If I was to search for height, I'm not actually going to find that. And this is a common thing just to help you out here with PCG. Sometimes you might see these nodes. You might see a tutorial that says add in this node, and you might not be able to find it. Just check the color of that node, because often it's a blue color. And what that actually means is it is an execute blueprint node. So you can see here, it's a dark blue. It says it's missing the blueprint. But if I come over here to the blueprint element type, this drop down here contains a whole bunch of other processes that are created using blueprints to allow us to do more operations within PCG. So it's not just all of these things that exist over here. Inside of this missing blueprint, we can also create our own and extend out and use these ones. And we will look at creating our own in the future. So inside of here, if I search, we'll go with height, and you can see there is a height to density operation, and that's what you might see if you're following tutorials. You might see that it shows this height to density, and it's this execute blueprint that's the indicator here to say what to look for. Okay, so what I'm going to do is I'm just going to move my reroute declaration here. I'm actually going to break the connection for that right now. Just put this in, and we should be able to see there's nothing there. So if I just debug this height to density, we should see it working actually pretty well just straight off the bat there with that. So if I just move this over, I'm going to keep the height to density visible for you, and I've got the height to density operation variables here. So you can see how what it's doing is it's taking this height inside of this volume and it's mapping that into our density. So where it's a certain height, it's going to be white, and where it's lower than that height, it's going to be black. Now we can change this gradient scale here. We can increase it, and you won't see much of a difference, honestly, when you go straight in. But as you get higher and higher, you'll be able to see that that pushes that gradient, and we can, depending on the actual slope and the difference in the gradient, you can see how we actually get some of those mid values back in here. Now, obviously, there's not a set value that I can just tell you type in here. This is going to be dependent on your height and the actual kind of things you're trying to filter out. Maybe you're trying to filter out, you can see here, only the very highest areas. So you can see this tiny little mound that I've made over here. Maybe I want to filter out so it only have that area. Or maybe I want to go all the way down and I just want to have a certain low point. Now, this point, if I go down, you can see as I go to 1 and go into the negatives, it's actually going to flip this over, which is really useful because obviously now we can go in the opposite direction and I can go down below this mid-value range of my volume. So I keep on going down there and I can get just the really, really kind of lowest areas. Okay, so I'm just going to drop that. Let's go back up to like 150 again. And you can see I've got these mid-value gradient kind of areas. If I go with this gradient offset, think of this as like a value that pushes this value up or down. So as I change this, you should be able to see it pushes it further up or it pulls it further down. So these are values that you can mess around with and change yourself. See, you know, I can pull that further back down, or I can push this all the way back up. I'm just going to leave it at 0 for now. But there we can see now we've got obviously a dark area down the bottom and a light area up at the top. And how can we use that? Well, we already know how we can use these. We can start looking at the values that we have there into a density filter. So let's look at this one and think, well, very, very light areas are probably going to be like 0.7 up. Let's just create one just for the recesses down the bottom. We won't use it in the video, but just for the purposes of showing you with a debug, I'm going to take this debug off and turn both of these ones on. So obviously now it's showing everything because I've got 0 to 0.7 and 0.7 to 1. If I was to turn this on and off, you can see how those light, only the lighter areas are actually showing up here. So you want to put things on the lower area, we can play around with this. If I was to turn that one off and just show just the highest areas, we can then obviously come in here with this height density and increase this scale. I can lower the scale and you can see the middle bit here. Now that's actually within the height boundary. So we'll start picking that up. And if I was to obviously go with just the other side of it, you can see where we can just filter out just the lower areas. So let's just plug this all back into what we had. That area there is going to be what we use for our ground cover. But if I plug it in, let's just debug this just before it's plugged back in. If I plug that in, obviously note that these are all white points here. So we've got two options that we can do here. And we can go back to the height to density for this one. The first thing that we can do is we could think about this height to density, and lots of these nodes, like the normal to density as well, I'll just show you with the normal to density. Whenever we're having this density mode, what we can do is we can choose to either set the density. So we basically say, whatever density it currently has, let's reset it and change it to a new value between 0 and 1. Or we can use these math operations here. So we could choose to take that 0 to 1 value and either add it on, subtract it, or multiply it to the existing value. And a useful one here is obviously multiply. Anything times by 1 is going to stay as it is. So we'd be able to retain the, if it was very high up, we'd be able to retain the normal noise that it has. And if it was a 0, so it was lower down, anything times by 0 is going to turn to 0. So we can just turn it to that black. So useful ones you could do here, you could choose that density mode to be a multiply, and you can see we've got more operations there with that kind of truncate integer to float. Or we could take this value, which we can see here is this very white, and we could drag off of there, and as we've done in other videos, we can look at it with a density noise. So I'll plug in this density noise, which will create an attribute noise. But the key thing here is it takes in the density value and maps that out into a 0 to 1. And you can see now only those high areas have been gained, but they've been remapped with their noise. If I put that into the top area here, let's just turn that debug off. Now you can see that I've only got my ground cover happening on those higher areas. And I can even go further. You know, I could obviously go to here and push that further up. And as I push it up, you can see it's pushing it further up the hill, so it only appears on the highest areas. Or I can go much, much lower, obviously, and push it all the way down. And we've got this filter over here. So what I could do is I could take this filter and I could obviously use that in the other one. So maybe I used it to have the bushes only appearing. There's lots of different things we can obviously then kind of start building into here. And you can combine it as well. So you could have this as a height filter to remove things that are at a certain height. Then you could have a normal filter to remove things that are on a certain angle, because you can see here I've still got this very steep angle, and that would mean that we only get things where it's flat and where it's high up. So combine these things, think about the different steps that you're going to need to do, and as we go through we should be able to obviously start compiling and building all of these things together so that we can choose where these PCG points are actually going to be created. Now, you might be in here looking at how you can filter out based on height. And obviously the example we've just looked through where we can use the height to density. So this example here using the height to density, this will work obviously, and I can filter these things through, but there is another way of doing filtering and doing it based on values such as like this height to density. And I will explore it in a little bit more in a separate video, but I just want to show you how we can use it here. So what I've done is I've created a completely new version of this. So you can see here it's got the ground cover, and I'll just connect this back up so we can see here now I've got this ground cover points, and if I go in here, it's spawning ground cover absolutely everywhere. Okay, so if we now go into here in this one, we're going to look at adding in a point filter. And point filters, I'll explore these more in a separate video, but they allow us to provide an attribute to filter out by. So rather than us having to go through and using the normal to density, the height to density, we can actually create filters based on a property. And in this case, the one I'm going to look at is if I go over here to target attribute, rather than filtering by density, I'm going to go to position. And the position I actually want in this case is Position.Z. So we're going to add a dot at the end and then a capital Z. And that's going to say, okay, if this value is greater than a defined value on my position of Z, so let's put this into here and filter this out, you can see what it's going to do is it's going to say, if this thing is inside of that filter, well, greater than, you can see we've got other options here like greater than or equal to, less than, or just exactly equal to or not equal to. So if it's greater than this Position.Z value, it will start appearing. And straight away, there you go. I've got some height control on there. Where does it know to get this from? Well, we can also go with this use constant threshold. So I plug that in, and now it's going to ask me, a float or a double. We're just going to use some kind of set value of what our height's going to be. The float value defaults to 0 here. Well, if we actually, let's just get this so we can see both of them at the same time. If I take in this value and just drag this up, you can see now I am defining, based on the actual Z of the world, I'm defining a value that this should be filtered out at. And if you want to know what those values are, well, an easy, quick way of it is maybe just to take a cube, throw this cube into the world. So I'll just press end just to drag it in. Or obviously you could zoom in a little bit and get the cube exactly where you want it. And we can look here and say, well, what is the Z value of that cube? It's 135. So if I was to take in maybe 130 and type in, that's going to be based on where that cube is. Maybe I drop it down a little bit more and play around with that value. Okay, so you can see there, I can play around with that. I can get that to be a set fixed value within the Z of my world. That's really useful for things like maybe you've got like an ocean level and you don't want any of your PCG to happen below water level, or maybe, like a river or something like that. So you can use this as kind of a hard fixed value to cut away from. But I just wanted to show you that because obviously we have got the height to density. We can also use this point filter. So I know it says here attribute filter, but you're looking for a point filter node, and we can here define what these are going to be. And I'm going to explore point filters in a little bit more in a separate video, and there's going to be lots of different things we can actually filter by, but the one we're looking at here for height is the Position.Z. And hopefully that gives you multiple tools, and you can use these now to start filtering out things, to appear on hills, mountains, or just on the opposite side, canyons, or restricting things from appearing above or below water level. Thanks for watching, folks. If you enjoyed this video, then please consider subscribing to access more of my Unreal Engine content.